a group, we're working in the back of your homework spiral on examples 1, 2, and 3. And you were supposed to be thinking probability of red or an ace. Hopefully you were thinking addition. And hopefully you were thinking probability out of a sample space of 52, no jokers. And hopefully you were thinking half the deck is red and 4 of them are aces. But why? Did I hear some of you asking the question, but why minus?
Because there is cards, both red and ace.
Yeah, are you getting it? When you count up all those cards, put them all back and count up the aces, well, 2 of them are. Is that cool? And we go ahead and say, okay, common denominator of 52, and then 26 and 4 is 30 minus 2 is 28. Or you could have just in your head added the 2 extra black aces. Does that make sense? Either way, you end up with, oh, that reduces, yeah? Good. Okay, so what do you guys think about jacks or hearts? 4 jacks. Of hearts. 1 heart. Well, 1 jack of hearts, right? So then you end up with 16 over 52. That reduces, true? But then everything changed. But hold on. I mean, okay. A die, we can kind of hold all the different options for a die in our for a dice. 6-sided die? 6-sided dice? Dice is plural, right? Dice, die. Got it. So when you're thinking about a die, you're like, okay, there's 6 different options. 1, 2, 3, 4, 5, 6. Easy. 3 or even. Well, let's just say we thought about them separately, like the formula kind of has us do. How many 3s are there in the 6? Just 1. How many even, though?
3.
2, 4, 6.
And minus, because 3 is even. What?
If you followed my logic, it'd be easy to make that mistake. But is 3 even?
No.
If 3 was even, I would have to subtract. But if 3 wasn't, oh, you guys haven't played those mind games where someone like leads you to say something wrong and they're like, bah, no, it's not. Yeah. Okay. Oh, but how do you subtract, and then not subtract? I was being tricky. But wait a minute. What's homework? Is homework all grouped together by whether or not you subtract? Hold on. Hi. Is homework grouped together by whether or not you subtract, whether or not its order matters, whether or not, or is it all just kind of mixed? What's the quiz going to be? So do you need to, well, by section, but once you get into the probability section, isn't it all kind of like who knows what will show up? So do you need to be able to be thinking, do I need to subtract or not? We don't need to subtract. 4 out of 6 is either or that, and so I end up with a probability of 2/3. So it's good to be caught off guard and be like, oh, wait, just because sometimes we subtract doesn't mean all the times we subtract. So let's go back to this idea one more time. Does it make sense that if there is an overlap, we could call these non-mutually exclusive, which is really awkward, and that's why I don't really say it. But non-mutually exclusive means they can occur at the same time, which means if there's overlap, I have to subtract. I subtract the and to find the or after adding. But if they're mutually exclusive, if it's a 3, it's not even. If it's an even, it's definitely not 3. If it's 1, it's not the other. There's no overlap. I don't need to subtract. But long story short, or what operation? Always addition, maybe subtraction. And what operation? Always multiplication, but sometimes, even though always multiplication, sometimes like subtract the red and ace, sometimes you don't have to multiply to find that. You're like, no, duh, there are 2 red aces. I'm just going to use it. So even though and is, if you need it, multiplication, sometimes it's just thinking about, okay, if they're both true, how many ways does that happen? And you don't always need to multiply to find that. Okay. I told you there was one concept. That was just practicing what we ended with yesterday. There was one concept we didn't get to go over. And I was like, let's see if you find it in homework, which is why I put that quick little note in your homework as far as where to stop. It was, I think I expected you to be able to get through one word problem, the one about going to college, not going to college, counting up and making fractions. But the next one I was like, it starts to get a little bit rough without this extra example. But there was one concept that I think you guys might have done fine on without learning it, but just in case. And to give you the vocab. Complementary events. Not like, oh, you're a nice event, not complimentary. That would be with an I, but complementary, like a complement of an angle. Supplement of an angle, complement of an angle. If you're ever in like a business partnership or in a marriage or any sort of depending on another person or needing to work with another person, it's hopeful, it's desired, it's ideal if you complement each other. I mean, hopefully that involves complimenting it every now and then, but if you complement each other, if you work together, if you as a result of coming together, improve the situation. Anyway, complement. This is a little different in the meaning, but it's still kind of coming together. Hey guys, what happens if the probability is 1 again? It's guaranteed because the percentage would be 1.00 or 100%, right? All probabilities of something happening should add up to 100%. So let's say, well, this will get a little complicated because we're kind of unique here. Out of all of our athletes that play a sport at this school, if we were to figure out what's the probability if you were to find an athlete just randomly, what sport they would play, like which sport is more likely for a student to play, et cetera, et cetera. We won't go into actually answering it. But let's say that we had a list of all of our different sports. Yeah? What are all of our different sports? Fall sports. We have cross country, we have volleyball, and we have football. True? True. Anything else? Nope, just those. No. Winter sports, though. Winter sports. Oh, well, that was a year long. I was going to do that one later. But yeah, we could do cheer. Okay, cheer. I wasn't leaving you out. Yeah. But you guys go all year. Okay, well, do you cheer for baseball or boys volleyball? You don't, right? It's competition and you just kind of, we don't care about you. Rough. Anyway, so coming back. Just kidding, just kidding. Just kidding. So we have cheer the whole year long. And then we have, lo siento, volleyball, football, and cross country. And then winter, then we add soccer, and we add more cheer. Yeah, I know. Basketball, true? And then spring, we add softball, baseball, boys volleyball, golf is in there somewhere, track is in there somewhere, and swimming is in there somewhere. And one year we actually also had equestrian. Yeah, we had tennis. Oh, that was fall. Oh, sad. Okay. So we have 13. We have 13 sports, and we didn't do equestrian because I don't think we have anyone currently in that. Do we have someone currently in equestrian? I don't think so. Okay, 13. 13. Well, that also reminds some of you guys that if there's something you're particularly good at, you could always be like, I want to pursue this, school, back me up, and maybe they will. Swimming, no, there you go. But coming back. So 13 sports total. If we take all of our athletes who compete for our school, we're not talking about clubs and extra, but our athletes that compete on school teams, if we have those 13 sports, and we figure out the percentages as far as the likelihood of competing in this one, the other, as far as the number of total students and the number per sport, what should all of those add up to? 100%. Because all of our athletes will be in one of those sports. True? So what's the likelihood? Not talking about a specific person, but what's the likelihood of being in this? How many students compete in this out of how many total? How many compete in this out of how many total? How many compete in this out of how many total? Ooh, wouldn't we have to subtract some overlap too? Anyway, but we're just talking about the likelihood of being in one of those sports. All of that, an athlete would have to be in one of those sports, right? What would be the probability of one of our school athletes being in a water polo team?
0.
There is no pool on top of the gym, even though people still talk about it. Oh, well, Mr. Jones, oh, you guys don't remember him. He had a picture of a pool being lifted off the gym from the crane.
Oh, what? Like OG Mr. Jones.
Yeah, OG Mr. Jones. Anyway, coming back. I know. He was a king. Coming back. Still is, just not here. The probability of playing water polo would be 0, but all of those probabilities would have to add up to 100%. So what if we had gone through 12 of the sports? What if we had gone through 12 of the sports and we were about to ask or find our last one? Would we actually have to do the work of finding the last one if we had done all the other 12? No. Because couldn't we do 100% minus all the other 12?
Yeah.
Oh, that's what a complement is. Chances of an event not occurring. And that sounds a little rough, but it's built on the idea of all probabilities of a situation, all possible outcomes. There's a quick little note I'm going to add at the bottom. All possible outcomes or all possible probabilities must add up to or sum to be 100%. All probabilities of a given situation all have to add up to 100% or 1.00. So based on that fact, if I'm trying to look for the chances of something not occurring, all I have to do is basically do 1 minus or 100% minus the probability of the event occurring. Notation would be P of not E. That's one way of doing it. I think our book also does E with like an apostrophe. There are a couple different ways of showing it. But the chances of an event not occurring, we'll figure out all the ways it could occur and then subtract from 100%. All the other ones are when it doesn't occur, or vice versa. If you want to know how or how many, what the probability is of an event occurring, you could figure out all the different ways it can't occur and do 1 minus. Either way, all of these have to add up to 100. So if we know all the ways it doesn't happen, do 1 minus, we'll figure out all the ways it does. If we figure out all the ways it does happen, do 1 minus all the ways it doesn't. Either way, everything has to add up to 100%. So we can, with this notation, say the probability of the complement, I'll use the book's notation. The complement of an event occurring is 1 minus or 100% minus the probability of the event occurring. Let's look at this example and see why on earth this could be helpful. A manufacturer has determined that a machine averages 1 faulty unit per 100% it produces. So from that, what's the probability of getting 1 faulty unit?
1 over 1,000.
1 out of 1,000. For every 1,000, you're going to get 1 that's faulty. Probability of getting 1 faulty is 1 out of 1,000. Okay. What is the probability that an order of 200 units will have 1 or more faulty units? Oh, the ors of that one. Could it have 1? Mm-hmm. Could it have 2? Mm-hmm. Could it have 3? Mm-hmm. Could it have 4? Mm-hmm. Oh, stink. Could it have 200? Mm-hmm. Be very unlikely, it seems, but it could have 200 faulty units. Is it going to take forever to add up all those ors? No? 1 or 2 or 3 or 4, all the way up to 200? I don't want to add up all the ways this will happen. I don't want to add up all the ways this will happen. I want to figure out, well, it seems like it can happen ways to have 1 or more faulty. The idea of a complement, everything adds up to 100%. Couldn't I do the probability of at least 1? Couldn't it be 1 minus the probability of when will this be true? What will have happened if you don't have at least 1 faulty? All good ones or no faulty ones, right? So to figure out the probability of at least 1 faulty, just say 1 or 100%, take away the none, take away the not, take away the opposite, which would be all good. Or no faulty, right? All good or no faulty. So hold on, what would the math for that be? All good. You open the first one, what's it going to be?
999.
You open the first one, it's going to be good. You open the second one, it's good. You open the third one.
It's good.
Ooh, is there a pattern to this?
Yeah.
You opened all 200, and they're all and then you do 1 minus. If they're all good, well, that one's good, that one's good, that one's good, that one's good, that one's good. What's the chance of that happening? Well, 999 out of 1,000. Wow, wouldn't that just be 99.9%? Wouldn't it just be the same thing? They're all good? Well, you guys do the math. If you raise 9.99 to the 200th power, does it still maintain its 99.9% probability? The chances of you opening one and getting it to be good, and the chances of you opening all 200 and every single one were good, is what? What's 999 over 1,000 raised to the 200 power? Point what? Give me some more. What? No, you had a 99.9% chance of getting a good one. Yeah, but not of getting 200 in a row. Your chances went way down. Which is why, if you're ordering something to be perfect, like centerpieces for a wedding, should you order exactly how many that you need? No, you always get extra just in case, right? When you have something that's like a high risk. Huh? Oh, so yeah, so Salma, when you subtract, what do you get?
No, because I get that, like...
Oh, you guys. I was wondering why it was so low. It's lower, though. What is it? 0.8? Thank you. That makes so much more sense. And then you end up with... But still, is it lower? Yes. Not much lower. It's not 99%. 1.9. But then 18.1%. But still, there is a chance, and it's much higher than the 0.1% of getting one bad one. 18.1% is a much higher chance of getting a bad one. Yeah. What's the common a bad one? This is getting a bad one. This is the chance then. Well, either you get a bad one or a good one. Well, or they don't deliver, you don't get any one. But that's a whole different situation. If you have a box, you're opening it, they sent the product, it's good or it's bad. Have to add up. This had to add up to 100. And then at least one versus all good had to add up to 100% also. So kind of use complement twice. Joe?
Is that a reason why engineering, they have something covered?
Okay, moving on. Boop. Oh, this one? Yeah. I need to change the single page. Hold on. And go back and then enter. Gotcha. You're welcome. Okay, I need us to look at one more thing in homework, though, because I had you stop at, what was it, 31, 35? Start at, or stop at 44. Can we go look at 44, and can I help you just a little bit? Because there was something kind of weird in 44. And to be honest, oh, well, actually, I have it ready. Look at this. Okay, number 44. You had to use some techniques from section 9.6 and 9.7, and it might have confused a few of you, which is why I said, okay, stop here. Do you guys agree that I pretty much wrote out the important information from the givens?
Yes.
Hey, is that what you're supposed to be writing out when you write out the problem details? Okay. And the directions, like what you're supposed to find? If you wrote this, you would have had 100% on the homework logistics. No, as long as you give descriptions on vocab. Some of you just stubbornly refuse to do it, so I'm like, fine, I'll stubbornly keep taking off points. Anyway, coming back. 108 cards total. It's kind of like Uno, true? You have red, you have green, you have numbers, and you have wilds. Uno minus the skips and the reverses, and that would get too complicated. Okay. And your hand is 7 cards. That's like Uno too. Probability of getting 2 wilds. Probability of getting 2 wilds in your hand. Does that mean that you pull the card and the first one has to be a wild, and then the second one has to be a wild, and then numbered? Or is it just you pick 7 cards, there are 2 wilds in it? Okay, so does order matter or not?
It does not.
Does not matter. It's just whatever's in your hand. Focus. I know you know, but I don't know. Coming back. Probability of 2 wilds. Combination. Order is important. If you have 2 wilds but 7 cards in your hand, didn't you have 2 wilds and 5 non-wilds? Don't you? Isn't that what you have in your hand? You have 2 wilds and 5 non-wilds? And then you have 7 total. This is kind of the idea. I'm going to put it in quotes, but the idea to the math as to how to solve. You need to get 2 wilds out of 8 total, and I don't care the order. You have 2 wilds out of 8. How many different ways can you get 2 wilds? And, or with, or together, out of the 100 non-wilds, getting 5. How many different hands are possible with 2 wilds? That's what this one calculates. How many different 2 wilds can you have? How many different 5 non-wilds can you have? And then the and puts it all together. I need wilds and wilds to make my 7 cards. But what's my sample space? Just 108 cards getting 7. How many different 7-card hands are possible with 108 if I don't care about the order? The sample space says I don't care. All 108, I'm getting 7. The numerator, though, fundamental counting principle, the and with a multiplication, kind of like section 9.6, multiplying to how many ways this can occur, how many ways that can occur. We're doing that top and the bottom and putting it in a fraction to make our probability. Can your calculator do all that for you? Use NCR. And alpha y equals fraction bar. What changes, though, if they say, okay, now, what's the probability of you getting 2 wilds, 2 reds, and 3 blues? What's my sample space still? Yeah, you're getting 7 cards still. How many different ways can you get 7 cards? Okay. But in the numerator, we have to say, oh, that needs to be true, and that needs to be true, and that needs to be true. So the 2 wilds, yeah, we just talked about. He was just saying this again, right? How many ways can you get? How many ways can you get 2 reds? Well, there are 25. There are tons of combinations. And how many different ways can you get 3 blues? How many different combinations of 2 reds? How many different combinations of 3 blues? How many different combinations of 2 wilds? Putting them all together. And how many different combinations of 7 cards? Does that make sense, guys? Yep. So, when will NCR come back? NCR will come back when you are having to put together or form on your own how many ways something can occur. If I ask you how many different ways can you get a black card from a standard deck, your brain says 26 out of 52. That's just based on your prior knowledge and your experience. You're like, I got this. It's all in my head. But as soon as I say, how many different hands of cards could you have with 2 wild, 2 red, 3 blue? There's no way our brains can contain all of that and think about all the different hands all at once and count them all up. It's impossible. So we need NCR to help us out. Does that kind of make sense? Okay. Kind of. But I think that should help you. That and the idea of a complement should help you now be able tonight to finish up section 9.7. Now, let's talk really quickly about logistics. Ambulances. Oh, we can't go over all. If you guys have not yet written down your test review, if I were you, I'd be writing it down. But let me talk about some logistics because our quiz is now on Thursday. Our quiz is now on Thursday. So the section 9.7 in Google Classroom, I think, wait. No. You don't need to post another picture of 9.7. You just need to finish it for your quiz, right? For when you turn in your homework spiral. Didn't you guys submit pictures already, but only up through 44? So I'm going to check to see if you finished it when I check your homework spiral on Thursday. Does that make sense? Okay. So should you finish 9.7 tonight? Yeah. But what's your actual homework tonight? The Chapter 9B review. Chris helped me out yesterday and was like, hey, you accidentally copied the 9.7 homework twice. You might need to refresh your Google Classroom because his didn't refresh automatically. But this is the correct... Oh, I'm sorry. I said test review. It's a quest review. Lo siento. Chapter 9A test was worth 75 points. This quiz quest part is worth 25 points. Way less, but still important. Way less, but still important. And they combine to be Chapter 9, 75, 25, 100 points, Chapter 9. But the quiz will be on Thursday. But wait a minute, why is the review due tomorrow when so many of us are going to be gone? So that the people that are in class can ask questions. So that those of you guys that work on it tonight, if you want, you can post like a comment in your Google Classroom on the assignment, like, hey, can you go over, and I'll record it. You can check out the video tomorrow night. But don't we normally have the review due on the day of the quiz? So I just want you guys to all attempt it tonight because we have an extra day anyway. That way, if you do have questions, it's probability. It can get tricky. You can ask me whether on a Google Classroom comment because you won't be in class, or in class because you will be in class if you're a junior or senior. And then I'll go over it on the video. That way you guys have a little bit extra to study for Thursday. Sound good? Yep. Okay. You're allowed to use your calculator on Thursday. But let me, for the last few minutes of class, do you guys mind if I give you particulars on the quiz now? Okay. So let's go ahead and either open up your homework spirals, write down your test review, and write some notes on the quiz now. I'd rather do it today than like tomorrow in the video. I'm hoping everyone checks out the video, but the likelihood, the chances, the odds, the probability, I believe is kind of low that absolutely everyone will check out the video tonight. All right. If you guys haven't written it down yet, if it is helpful for you to know, once again, you are able to think about the points as far as how many points in Chapter 9A and Chapter 9B. And that the test, the test you guys are going to get back before the end of class. People who are in class, if we run out of review questions and they're already done on it, they can start working on their corrections. People not in class, it's not going to be due right away. We talked about that yesterday. But the first part was worth 75 points. This part will be worth 25 points. All right, let's see. There's going to be questions possibly on the whole computer generating integers. Remember we talked about that quite a few times. There's going to be questions in 9 or from 9.6, and you are going to know it's from 9.6 by two things. One thing is that somewhere in there should be something to do with how many. Find the number of ways or how many or both. If you see or if you read the words how many or the number of ways, that's section 9.6 where the numbers were big. Maybe they were like in the 10s and the 20s and the hundreds. Maybe they were in the thousands or the millions. The numbers are big because you're just counting up how many ways it can occur. What are some funny types of problems? NPR, NCR. Remember how you're allowed to use your calculator, but what did I say with NPR, NCR? Maybe show the steps, or I'm going to at least on one or two of them have like a blank with show me the factorial formula to get full credit. You can use your calculator for the final answer, but know the factorial formula for filling in the blank. Ooh, do you guys remember something weird in section 9.6 to do with repeated letters? Oh, yeah. Like Mississippi. Might want to write down that one to look over. And I even had you like highlight it when we were there, saying most kids forget to study it. Repeated letters. And since we're talking about NPR, that was new. We talked about NCR before, but NPR is new. Do you remember that NPR is used whenever you read something to do with arrangement? Or they can even use the word permutation, or something to do with order being important, right? Permutations, order is important. Combinations. Well, we just saw an example of combinations, like cards in a hand. I don't care what order. Combo pizza. I don't care what order. People in a group. I don't care what order, right? People on a committee. I don't care what order. Classes that you're taking. I don't care what order. Giving too many hints. Okay. But as soon as they start asking for probability slash chances, what are the chances? Slash, what are the odds? Probability, chances, odds. What new formula came up? The fraction, right? As soon as probability, chances, odds, now all of a sudden we have fractions and decimals and percentages. The probability of an event happening equals the number of ways or the number of favorable outcomes over the sample space. And that's not really something that I'm going to make you like write down somewhere, but you're going to have to probably use it. Sometimes I will give you probabilities and you have to put them together. I will give you fractions or give you decimals and you'll have to put them together with ands, multiply, ors, addition. But sometimes I give you the details and say, you figure out how many ways this can happen. Kind of like the cards. They didn't give you fractions or decimals or percentages. They gave you cards and you had to figure it out. So sometimes I'll give you the fractions, the decimals, and this is for you to look for sample problems. Sometimes I'll give you fractions, decimals, percentages, and you have to put them together properly with ands or ors or complements. But sometimes I'm going to give you the data and you have to form the fractions. Just a few of you might want to write down the following words that might show up that should point you in a certain studying of examples. What if you see the word not with probability? What if you see the word both? What if you see the word at least? And what if you see the word exactly? Important words that you might see tomorrow. Kind of makes sense, guys? I think I gave enough for you to be able to very specifically study, yeah? One person from every group, go on back and grab a correction paper. I'm getting you your Chapter 10A test today. That way everybody has them. Some people will be correcting them tomorrow. Some people are like, I won't care until after the quiz because it's not due until Friday anyway.